AIDS department. Today I am here to explain about performance comparison of multiple machine learning algorithms for iris flower classification under the guidance of Dr. Ashwini J. Ma'am. The agenda of the project is statement of the project, purpose of your project, proposed methodology, expected results and applications, literature review, project plan, and conclusion. Introduction for the project Iris Flower Classification using Machine Learning. This project is through application of machine learning with Python programming. It focuses on iris flower classification using machine learning with SKIT tools. Here, some of the algorithms are used that are some of types of machine learning subparts algorithms of supervised and unsupervised. Algorithm used for predicting and get accuracy are decision tree classifier, k nearest classifier, SVM, logistic regression. Statement of the problem. The classification challenge is the challenge lies in developing an automated system that can accurately and instantly classify the species of an iris flower. This involves overcoming the limitations of manual classification and determining the optimal machine learning for the task. The problem is to develop a machine learning model capable of learning from these measurable attributes and accurately classifying iris flowers into their respective species. Scope of the project. Focus on using Python and machine learning libraries for the classification engine. Develop a machine learning model to accurately classify iris species based on sepal and petal measurements. Target guidance. Botanicists, researchers, and students in the field of biological data science. Deliverables. A trained and evaluated machine learning model, a user-friendly interface for model deployment, documentation detailing for the model's architecture, training process, and performance metrics. Iris flower classification inclusions, data collection from standard datasets, feature selection and engineering, build prediction portal using the MERN stacks. Exclusions are not covering all iris subspecies, no real-time sensor integration. The methodology, data collection. The first step of the project is to collect the iris flower dataset, which contains measurements such as sepal length, sepal width, and petal width for three species: Setosa, versicolor, and Virginica. This dataset serves as the foundation for the training, evaluating the machine learning models. Second one, data processing. The collected dataset is pre-processed to improve data quality and ensure better model performance. This includes handling missing values, normalizing numerical features, and splitting the dataset into training and testing sets. Machine learning model development. Various machine learning algorithms such as logistic regression, k nearest neighbors, decision tree, and support vector machine are implemented to classify the iris flower species. Model evaluation selection. These trained models are evaluated using performance matrices such as accuracy, precision, recall, and confusion matrix. Integration and testing. The selected machine learning model is integrated with the interactive interface. Iris flower classification process includes collecting the dataset, understanding feature standards, selecting relevant features, applying data processing techniques. Machine learning model development includes collecting and preparing data, choosing a suitable algorithm, building an accurate model, simulating predictions. Architecture diagram. Iris flower classification using learning with interactive interface. Data and collection and pre-processing to machine learning model that to prediction and result display. Design use case diagram. Use case diagram in the iris flower classification using machine learning with interactive interface. The use case diagram represents the interaction between the user and the classification system. User to enter flow measurements, pre-process data, classify iris flower, view prediction result. Design class diagram. A class is a representation of an object and it in many ways. It acts as a template from the objects are created. Classes from the main building blocks of an object-oriented application. Sequence diagram. User to interactive interface, pre-processing module, machine learning classifier, and results display. The algorithms used in the project are support vector machine. Support vector machine is a supervised machine learning algorithm used for classification problems and it is used to classify iris flowers into three species: Iris setosa, Iris versicolor, and Iris virginica based on the sepal and metal measurements. It's worked by finding an optimal hyperplane that best separates the data points of different classes. Hardware and software selection. Processor Intel Core i3 or above. RAM minimum 4 GB, 8 GB also recommend. Storage minimum 20 GB free disk space. System type 64-bit system. Input device keyboard and mouse. Output device monitor. Implementation. The project is implemented by Python using the following libraries: NumPy, Pandas. The project is implemented using Python with the help of the various machine learning libraries. The project includes Python scripts that are used to load, pre-process, train, and test the iris flower dataset. This iris dataset is loaded either from a CSV file or directly from the scikit-learn library. Implementation. Data processing techniques such as feature normalization and train test splitting are applied to improve model performance. Multiple machine learning algorithms such as logistic regression, care nearest neighbors, support vector machine, and decision tree are trained using the data. The trained models classify the iris flower into one of the three species: Iris setosa, Iris vercosa, and Iris virginica. Important quote segments. The results of the project are: the project achieved a maximum accuracy of 94.7% observation. Models like KNN and Naive Bayes are extremely effective for this dataset because the species are well separated in the future space. Thus, outcome: the system successfully classifies the three species of iris flower with very high reliability. The conclusion. In conclusion, our model proves the machine learning can effectively automate the classification of botanical species with near perfect accuracy, reducing the need for manual expertise in simple taxonomic tasks. Based on this result, I selected the naive Bayes algorithm for the final implementation. While other had the same accuracy, naive Bayes is computationally efficient and works well for small dataset like this one. The project proves that we can successfully automate botanical classification with high precision, reaching a level of accuracy that matches or even exceeds manual human identification. Future work. Looking ahead, the next step for this project would be to move the numerical data to image data. I plan to implement convolutional neural networks so that a user could simply take a photo of a flower and get an identification. We could also deploy this model as a mobile application using a framework like Streamlit, making it a portable tool for botanicists and researchers in the field. References: Viniar Preeti KP, Iris flower classification using machine learning, international research